the characteristic equation, that is lambda cube minus 6 lambda square plus 14 plus 8, 22, 22 minus 11. That means plus 11 lambda minus 6 is equal to 0. Okay. Therefore, on solving this one, you will get lambda equal to 1, 2, 3. Solving this equation, you can use calculator. Otherwise, the last day I have shown you how to solve this one. So, you can use that method or directly using calculator. So, lambda equal to 1, 2, 3. These are the eigen values. And here these eigen values are distinct. Okay. So, when it is distinct, method is different. When they are same, method is different and all. So, here lambda equal to 1, 2, 3, the values are distinct. These are the eigen values. So, for a 6 mark question, this will be for 2 marks and remaining will be for 4 marks. Or for 8 mark question, this will be for 2 marks and the remaining will be for 6 marks. So, these are the eigen values. Now, we need to find the eigen vector. So, case 1, so to find the eigen vector. To find the eigen vector when lambda is equal to 1. So, you need to take lambda equal to 1, 2, 3, all the values. So, when lambda equal to 1, let the eigen vector be, a minus lambda 1 I into x. Say x1 equal to 0 or simply take x. Okay. So, lambda equal to 1, eigenvector is a minus lambda I into x1 equal to 0. That is, what you have to do is, here we consider the matrix only, a minus lambda into I. A minus lambda into I means lambda, put lambda 1. Lambda 1 is equal to 1. Okay. Then lambda equal to 1, eigenvector be a minus lambda 1 into I of x1. This lambda 1, I have taken this as the value 1. Okay, so now what you have to do is, in this equation, in this one, put lambda equal to 1. Here this is determinant, but we are going to consider the matrix. So 8 minus 1, minus 3 minus 1, 1 minus 1. Okay, in this equation, in this determinant, we are putting lambda equal to 1, but we are considering the matrix only here. So 8 minus lambda means 8 minus 1, 7. Then minus 8, remaining all will be same, minus 2, then 4, minus 3 minus 1, so it is minus 4, minus 2, 3, minus 4 and 0. Okay, then now here this x1 we will consider as x1, x2, x3 because this is vector. 3 variables will be there because 3 by 3 order matrix it is. So, we consider x1 as x1, x2, x3. This is equal to right side 0. 0 means 0 matrix. So, 0, 0, 0. Okay. So, this is a eigenvector what we are going to get from this. Okay. From this you will get the eigenvector. So, now to solve this one, the process is, firstly, you will reduce this to an echelon matrix. Reduce this coefficient matrix to an echelon matrix or to echelon form. Echelon form, I hope you remember. Echelon form means you will reduce the last row 0, then you will reduce the second rows to 0. Means maximum possible zeros you will bring in this one, considering or keeping maximum number of zeros at the last row. Okay. Now, why we are doing like this? After finding the echelon form, you will get the rank of this matrix. Then, getting the rank of the matrix, you can say how many independent vectors will be there. Okay. So, to do that one, first of all, you will reduce this to echelon form. Now, to reduce this to echelon form, you will perform only which transformation? Row transformation. Row transformation you will do. Okay. So, this coefficient matrix is there. So, my first aim is to make the last row zeros. Last row we need to make 0. So, for that I will do here, say R2 minus, because here it is 3. If here it is 3, you can subtract that. So what I will do here, any method you can do, only thing is that you need to do row transformation. Any other change? No. If you directly multiply this one, just multiply and solve and see, you will get the answer 0, 0, 0. Because the right side, all right side is 0. If you are directly simplifying, getting, you may not get the answer always. Sometimes you may get, but always trivial solution will be there, 0, 0, 0 trivial solution, and it is not necessary that always you get that one. Okay, so R2 minus, this is a safer method, that is reduce this to the standard, means echelon form. So R2 minus R1, if I do 7 minus 8 minus 2, and that reduction method you need to do in the coming methods also, coming types also. So it is better to go now only with that method. So R2 minus R1. So R2, this R2 is changing. 4 minus 7. 4 minus 7 is minus 3. Minus 4 minus minus 8. So how much it is? Plus 4. Minus 2 minus minus 2. So minus 2 plus 2, 0. And here 3 minus 4, 0. Okay, same as it, only R2 we changed. X1, X2, X3, right side 0, 0, 0. Okay, now that is equal to, now if you do R3 plus R2, here R2 is changing, R2 changes to this one, here R3 is changing, R3 changes to R3 plus R2. So it becomes 7 minus 8 minus 2, then minus 3, 4, 0 and 0, 0, 0. Okay, now x1, x2, x3. If all the three equations are different and if rank is 3, number of unknowns is 3, then it is easy to solve using equations. Like you told, making equation directly you can solve. But it is not necessary that always you will get the solution in that way. So now, again, now what my aim is, I will try to make this minus 3, 0. Now if I am going to make this minus 3, 0, what will happen? Let's see that. Okay, this minus 3 will make 0. So if I do 7R2 plus 3R1, if I make 7R2 plus 3R1 0, this transformation, this term will become 0. Because 7 into minus 3 minus 21, 3 into 7 plus 21, minus 21 plus 21, 0. Okay, so this term becomes 0 and this will change correspondingly. And here some number again will come. Okay, but that is not going to help us in any way. It will not be helping us in any way. So I am not doing further simplification here. Only this one step will do, 1 or 2 steps will do. Okay, now take this equation. Now I am going to consider this equation. Now here what happens is, rank of this matrix is 2. Rank means number of non-zero rows. Number of non-zero rows, that is the rank. And number of unknowns is, that is 3. Unknown means x1, x2, x3. 3 unknowns are there and rank is 2. Therefore, you can give, or n minus r independent solution will be there. Okay, so independent solution or independent vector, there are n minus r independent solution or independent vector will be there. That means n minus r means 3 minus 2, that is equal to 1. Out of this x1, x2, x3, for any one value you can give some arbitrary constant. Okay, that means, so I will write that, then you will get it. So now from this equation, equations I am going to write. First one 0 into x1, 0 into x2, 0 into x3. So both sides LHS are 0, 0, 0 you will get. Second equation from here, second row, minus 3 into x1 plus 4 into x2 plus 0 into x3. Okay, so that is equal to 0. one equation. Now from the first one, first row, 7 into x1 minus 8 into x2 minus 2 into x3 is equal to 0. Now if you are going to solve this equation by any way, calculator or by any way, you will not get the solution because this is 3 unknowns are there. 1, 2, 3, x1, x2, x3, 3 unknowns and 2 equations. So you cannot solve this one. Okay, so that is the reason why we go by this rank method and all. Now this n minus r equal to 3 minus 2 equal to 1 means out of this x1, x2, x3, any one which you like, you can give some arbitrary constant t. Okay, so for that, suppose I am going to put x2. x2 is equal to anything you can give. x2 equal to, say I am going to give t. x2 is t. Okay, so from here what you will get, x2 equal to t or x1 equal to t as you like, or not only necessary the key, only 2. It can be t by 2, 2t, 3t, 5t, so that the simplification will be easier. I will show you now what I am doing. So minus 3x1 equal to minus 4x2 will come. Okay, from here minus 3x1 is minus 4x2, or from here x1 is equal to minus 4 by 3 x2. Okay, minus 4 by minus 3 x2, and here I will get minus 4 by minus 3 means plus 4 by 3 x2 is t. So here this fraction comes, but I don't want that fraction. Okay, I do not like to keep that fraction, so I can take this x2, value of x2 as something good, like means where there is no fraction. So I can keep this x2 or x1. Suppose I am taking x2 is 3t. Okay, therefore here minus 3x1 is minus 4x2. Therefore this is equal to minus 4 into x2 is 3t. That means minus 12t. Minus 3x1 equal to minus 12t, or x1 is equal to 4t. Okay, this is why I did this one. I do not want to keep the fraction. Okay, if you are comfortable with keeping fraction, it is okay. You can take x2 equal to t, t by 2, 2t, 3t, anything like that. So only thing that I don't want that fraction there. So just I put x2 equal to 3t. Okay, this you can take anything here. Not only t, t1, t2, anything you can take. So now from this equation, second equation, 7x1 equal to, I am taking this to the right side, 8x2 plus 2x3. So that is equal to 8 into x2. x2 what we have taken, 3t, plus 2 into x3. Sorry, x1 you got, we need x3 from here. So 7x1 minus 8x2 equal to 2. Because we have x1 and x2 here. So 7 into x1, 4t, minus this is equal to 2 x3. Okay, so 7 4s are 28t minus 8 3s are 24t is equal to 2x3, or from here 2x3 is equal to 4t, or x3 is equal to 2t. So x1, x2, x3 we got. Okay, therefore x1 is equal to, x1 was our vector, x1 was x1, x2, x3. Okay, so that is equal to, x1 means it is 4t, x2 means it is, x2 what we have taken, 3t, and x3 is 2t. Therefore this is equal to 4, 3, 2, and t outside, t is taken common, so t is taken outside. So this is the eigenvector corresponding to the value lambda is equal to 1. Okay, therefore the eigenvector can be 4, 3, 2 or any multiples of this 4, 3, 2. Means some may get the answer, after solving some may get the answer as 8, 6, 4. This is also right, because here t is taken as 2. Okay, any constant value. So it can be, this eigenvector can be any multiple of this 4, 3, 2. Okay, so that is the eigenvector corresponding to lambda is equal to 1. Therefore, eigenvector corresponding to lambda equal to 1 is 4, 3, 2. This can be column vector or row vector. 4, that depends on how we are choosing it, how we are writing that one. Is or transpose of 4, 3, 2, that means 4, 3, 2 row vector also. It can be. Okay, so this is the first one. Now, lambda is equal to 2. When lambda is equal to 2, same process you need to do. When lambda equal to 2, again the first equation, let a minus lambda 2 into I x2 is equal to 0. Okay. Now, here lambda, you can keep it as m minus lambda 2 I into x1. Again, you can take, or simply x you can keep. Not necessary always to keep x1, x2, x3, etc. So, here x1 you have taken. So, you can give this as x only. In the three cases, the equation will be different only. So, no issue in that. So now when lambda equal to 2. So for lambda equal to 2, you will get the matrix. Means here what we have to do, from this you need to minus subtract 2 from each diagonal elements. Okay. So the equation you will get there, that is 6 minus 8 minus 2, 4 minus 5, means you are subtracting lambda equal to 2 from the diagonal elements. And here 3 minus 4 and minus 1. Okay. So this is the matrix, coefficient matrix. 6 minus 8 minus 2, 4 minus 5 minus 2, 3 minus 4 minus 1 into x2. Again x2, x1, x2, x3 equal to 0, 0, 0. Okay. Now again the same process. Now somebody asked me, can we solve this equation directly transform? See now, look at this row 1 and row 3. What you are seeing here, row 1 and row 3. If I take 2, if I divide this 2 by 2, if I divide row 1 by 2, you are going to get row 3. No, 2, this will be divided by 2, means 3 minus 4 minus 1. Here also 3 minus 4 minus 1. Okay, so you will not be able to solve this equation, or you will not get the equation, and if at all you get the equation, it is difficult to get the solution. Okay, that is the reason why we find the rank. So now here to get the rank, or it's very easy to solve this one. Now suppose I am doing R1 changes to R1 minus 3R3. Okay, or firstly you can do R1 changes to R1 divided by 2, that also can be done. So let's do that. R1 changes to R1 by 2. So this becomes R1 by 2, 6 by 2, 3 minus 4 minus 1, then 4 minus 5 minus 2 R2, and R3 as it is 3 minus 4 minus 1, and here x1, x2, x3 equal to 0, 0, 0. Okay. Now R1 change, R3 changes to R3 minus R1, because both are same only. So subtracting, that row will become 0. 3 minus 4 minus 1, 4 minus 5 minus 2, 3 minus 3 0, minus 4 plus 4 becomes 0, and this also 0, x1, x2, x3. And here 0, 0, 0. And here try whether you are getting these zeros. Means if you are getting, I hope many of you remember, rank means number of non-zero rows. So suppose here after transformation, suppose here again you are getting 0, 0 and here minus 2. Okay, then also the rank will be 2 only, because it is a number of non-zero rows. Now suppose after solving here again you are getting 0. Then the rank will be how much? Rank will be 1. Okay, so if at all there is single term is there, if there is any single term in this row, then also it is considered as non-zero. Okay, so here it is minus 2, 4 minus 5 minus 2 it was. No? So here the rank is 2, because again if you are trying to reduce this 4 to 0, here some non-zero number is going to come. Okay, so anyway we cannot reduce this second row completely to 0. So it is useless to solve again and again. So from here rank is equal to 2 and number of unknowns is equal to 3. So like in the previous question, either you can give x1, x2, x3, any one of that you can give us some t constant, arbitrary constant. Okay, so from here I am going to write the equation. So it is minus 4x1 minus 5x2 minus 2x3 equal to 0, second one, and the first one 3x1 minus 4x2 minus x3 is equal to 0. Again you can reduce these numbers to smaller numbers, that is there, but it's of no use. Again and again we can just go on simplifying, it's of no use. So now here I want to get the value of x1, x2, x3. So suitably anything you give as t. So I am putting here Khan Muskan plus 4 into 1, where it is 4, oh right, 4, 5. Now which one? What you are telling? Plus 4, 3 minus 4 minus 1. Equation 1. Right. Equation 1 is 4x1 minus 5x2. Right, good, thank you. Minus 2x. Now put x3 equal to t. I am putting. Okay, x3 equal to t. Anything you can put x3 equal to t by 2, t 3t, 2t, anything you can put like that. So I am putting, and that can be given to x1, x2 or x3, any one value you can take, because here r is 2, n is 3, so n minus 3 minus 2 means one variable can be given any some arbitrary constant. So x3 equal to t I put. Therefore from this one, this say I am putting equation number 1 and 2, it will be easy for you there. Then from equation number 2, 3x1 minus 4x2 minus t equal to 0. Okay, so from there you will get, so from here you will get one equation, and equation number 1 will become 4x1 minus 5x2 minus 2t is equal to 0. Now we can solve this equation. R2 changes to R2 plus 2R1 I will do. R2 minus 2R1. Okay. So then this becomes 0. 3 minus 4 minus 1. Last row will remain 0, 0, 0. R2 changes to R2 minus 2R1. So first term will become 4 minus 2 into 3. 4 minus 6. So it is minus 2 here. Then second term minus 5 minus 2 into R1. R1 means minus 4. So that is minus 5 plus 8 will come, or this is 3. And third term is minus 2 into minus 1. So minus 2 plus 2, this is 0. Okay, now it will be easier for you to solve. Ma'am, can we get before doing row transform first we can do? Yes, you can do, means see, transformation, any row transformation you can do. Only thing is that you need to do row transformation only, because echelon form. That can be in R1, R2, R3, anywhere. But at the end, echelon form has zeros in the last row. At the end of that step, you must write the row with zeros as the last row. Okay. So now here n equal to 3, r equal to 2. So now from this one equation we are going to write. So minus 2x2, minus 2x1 plus 3x2 equal to 0. This is a first equation, and the second one 3x1 minus 4x2 minus x3 equal to 0. Say equation number 2. Now here see, in the first equation x3 is not there. Second equation x1, x2, x3 is there. Okay. So here you can put x3 equal to t, because n is 3, r is 2, so any one variable can be given this arbitrary constant. So x3 equal to t I put. Therefore from equation number 1, what you will get, minus 2. In equation number 1 there is no x3. From equation number 2 you will have, 3x1 minus 4x2 minus t equal to 0. Okay. Therefore from here, and from equation number 1 you will have minus 2x1 equal to 3x2. Then now we will solve these two. We will solve these two and we will get the answer for that one. So for that, from here t is equal to 3x1 minus 4x2.